Okay, so welcome back, everyone. This is sketching polynomial functions part 2. Part 1, we didn't really sketch much. We just looked at multiplicity of roots and things of that nature. We're going to go back to that in not too much more time. But right about now, okay, I have presented you with a graph. We do not know what the equation is, but we're asked for some bits and pieces of information here. And some of this is new, particularly part E is new. Okay, so why don't we take a look at this? And also, you're going to want to have your end behavior chart handy because we're going to be using that for at least one of these 5 questions here. So first of all, okay, let's take a look at part A. It's asking for the degree, and this is definitely a degree 3 function. How do I get that solution? You can get that in many ways. Okay, you can look at the number of x-intercepts. We have 1, 2, 3 x-intercepts on the graph, and they're all multiplicity 1, right? They just cut through the x-axis. They're just your regular standard x-intercepts. So you can count the x-intercepts in this case in their multiplicity, and you would get a total of 3 with 3 roots with multiplicity 1 each. Or another way you could do this is you could look at the number of waves that the graph has. If you move from left to right, you can see that it goes up, down, up. So that's another way of knowing it's a degree 3. And then the sign of the leading coefficient in part B, how do you know that? Well, you can look at your end behavior. We've already established that it is an x to the 3, a degree 3 function, which is odd. So you look at your even or odd degree functions, and you can see that this one is a positive x to the 3 graph because it starts in quadrant 3 and ends in quadrant 1. Okay, you're not actually asked for the end behavior, but that's one way of you can look at the graph and see what the end behavior is and then match it up to the sign. One thing you probably have already noticed with your end behaviors is that if it's an odd degree, you can see that the positives start on the left by moving up, down, up, and then you can see that the negative odd degrees start on the left by moving downwards, if that's a way that you want to remember. Okay, so this is definitely a positive x to the 3. Technically, you're only asked for the sign, so really the answer is only just the positive part. But I threw in the x to the 3 and the m behavior as well. Really, the answer is just positive. The x-intercepts, well, you could have done that before even doing this unit. Okay, you can just look at the graph and see what the x-intercepts are. You could see that we have x is equal to -4, -2, and +2. And those are the x-intercepts. Now we can establish the factors, which are the opposites. So x plus 4, x plus 2, and x minus 2 are all the factors. Right? The factors are the opposites of the x-intercepts. And then part E is definitely something new. Okay, you are asked for the intervals where the function is positive and then the intervals where the function is negative. Okay, so here goes. All right, we're going to give the intervals for each one separately. So I do a positive and a negative one. This is the very simple shorthand notation that we can use. And essentially what you're asked for is domains. Okay, you're looking for the x values at which the function is positive. So we're going to write domains for each of these. And I saw in Miss Johnson's class that you guys are doing this new shortcut way for domain and range. So we're going to stick with that in this class. Okay, you could write it the old way with the less than and equal signs if you want. And as long as it matches up, you're okay. But I feel like this way is actually easier. And you're going to see answer keys written in this format. So maybe it's a good idea to jump on this. So first of all, okay, what does it mean when a function is positive and when it's negative? Okay, the answers are the x values. And if a function is positive, it means where on the graph is the y values positive. In other words, to get the positive values of the function, we're looking at where on this graph is the graph above the x-axis. So you can see that the graph is above the x-axis in 2 places. It's above right here between -4 for x and -2. So we can say from -4 to -2. So remember that we put our left bound first and our right bound last. They have to be in the right order. So we always move from left to right with the graph. And within the intervals, each interval starts with a left side interval and a right side interval, like -4 to -2. And notice I use round brackets because we're not actually including those numbers, because at x equals -4, the y value is not positive, it is a 0. Okay, and same thing with -2. And then we have this other positive part right here, which starts at x is equal to +2 and doesn't really end on the right side because it's an arrow that goes to infinity. So we would just say from 2 to infinity it's positive. And then similarly, okay, the negative parts are where in which x values, which domain is the graph below the x-axis. And we see it right here. Again, we have to start on the very left. And within the very left, we have to start with left bound and right bounds. So you can see right here, the left bound of what I just circled there is -infinity, right? The x value is -infinity. And then that goes to the right boundary of -4. And then, of course, we have another section of the graph where the graph is below the x-axis, and that is this section. And that goes from -2 on the left to +2 on the right. And then we have this finished. So there's some more questions like this that you may want to try out on page 148, number 4. Try out those questions, and it's more questions like these, and then we'll return with part 3.